First, insert the Arduino Nano. Then you insert the LED. Here, the right terminal is the anode and the left one is the cathode. You then insert the resistor to the anode terminal. Then the cathode of the LED goes to the ground pin of the Arduino Nano. Now the anode through the resistor is connected to D2 of the Arduino Nano. Connect the cable to the microcontroller in the PC. When you open a new sketch, by default these two functions appear: the setup function and the loop function. The setup function runs once after each power up or reset of the Arduino board. Inside the setup function is where we write codes, or in other words, statements to initialize variables, start using libraries, and set pin modes. The loop function, codes written in here runs over and over as long as the Arduino board is powered up. From the circuit, the anode of the LED was connected to the digital pin D2 of the Arduino Nano through the 220 ohm resistor. So to control the LED, we have to set D2 as output such that we can attain 5V or 0V output to blink the LED. To do that, the pinMode function is used. Basically, the pinMode function is used to configure a specified pin to behave as an output, input, or input puller. So the syntax for writing a pinMode function is pinMode into bracket the pin, in this case D2, so we write 2, comma, then the mode, in this case output, we bring a semicolon. For easy identification, let's create a variable to hold these two, so that we can replace it with the name of the variable. To do that, we will create a global variable. A global variable is a variable that can be seen or accessed by every function. They are usually written before the setup function. So we bring our cursor here, we hit the enter button, then we move it up. So to create the variable, the data type is first written. In this case, we are using the integer data type, and it's written like this. We are using integer because this data type allows us to save whole numbers, followed by the variable name. I'll use LED. Then we assign the value 2 to the variable. So what this line of code means is that LED is equal to 2, which means that we can now replace this 2 with LED. Furthermore, we can add const to the variable to make it a constant variable, since the 2 will be unchanged. So this is the syntax for declaring a constant variable. Now we move to the loop function. Here we are going to write the main code to blink the LED. So the procedure is return the LED on for half a second and turn it off for half a second to cause the blink effect. To turn the LED on, the pin 2 to which the LED is connected to has to provide an output voltage of 5V. To do this, we use the digitalWrite function. So the syntax is digitalWrite into brackets the pin and its LED, then the value. The value can be set to either high or low. At high, 5V is supplied, and at low, 0V is supplied to the specified pin. We want 5V at the pin, so we type high, then our semicolon comes. Take note of this syntax. As you can see, the W is a capital W and the high is in uppercase. So at this point, the LED is on. To keep this on state for half a second, the delay function is used. As the name suggests, it delays or pauses the program for a set time in milliseconds. The syntax is delay into brackets the time in milliseconds. Take note that the value for the time is in milliseconds, where 1000 milliseconds is equal to 1 second. Similarly, 2000 milliseconds is equal to 2 seconds. So for half a second, we will write 500. At this point, we want to turn off the LED for saying 500 milliseconds delay. So we repeat our digitalWrite function. The pin is LED, and here at the value we choose low because we need a low voltage or a 0 volt at the pin. This line of code turns off the LED, and to delay it we add delay 500 milliseconds, our semicolon. This is the complete code to blink the LED. At this point, the LED goes on. It delays for 500 milliseconds. The LED goes off and also delays for 500 milliseconds. This line of code runs repeatedly since it's in the loop function. One more thing to note, codes written inside a function must be in between the parentheses of the function. So as you can see, these codes are inside, and here at the setup function, we have them inside too. So let's verify our code. We click verify. Done compiling. This means that our code is error free, so we can now upload it to the board. We click upload. When the upload is done, our LED should start blinking. Done uploading.